Welcome hires to lesson 8 of higher chemistry. So as usual, quick wee starter here. So question 1, what type of reaction takes place when we make bonds? What type of reaction takes place when we break bonds? Okay, question 2, assign the correct sign to both A and B. So is it going to be a negative or is it going to be a positive? And question 3, calculate the enthalpy change using bond enthalpies for the following reaction. Okay, so pause the video, do the starter. I'm going to go through the answers just now. Right, so what type of reaction takes place when we make bonds? So remember, we've got our two bonds here. We make, they collide, and they release energy. So if we're releasing energy, that makes it exothermic. Okay, and I'm just going to do question 2 just now. Assign the correct sign. If it's exothermic, it's going to be a negative sign. Okay, and you need to know that. Right, what type of reaction takes place when we break bonds? Again, I'm just going to put this pencil back together because I don't have many. So again, if we've got an atom on either side, so we've got a H on the right, a H on the left, if we want to break this bond, which is represented by the pencil, we need to put energy in to it. Okay, so if we put energy in to breaking the pencil, that makes it endothermic. Okay, and that's got a positive sign. Again, you need to know that, otherwise we would never be able to do question 3. Right, so first step, we draw the molecules out. Okay, so the easiest one to draw out is probably I2. So let's just draw that. Yeah, and we've only got 1 mole of that. Don't get confused, don't draw 2 of them. Yeah, it's 1 mole we've got. And C3H6 is propene, so we've got 3 C's. And remember your carbon to carbon double bond. Okay, just like that. And this one here, again, it's just a basic addition reaction. You did these in National 5. The double bond breaks and the 2 I's add over. Just go. Yep, the 2 I's add over like that. Now, you might be thinking C3H6, it does have an isomer, and its isomer is cyclopropane. However, we should be able to confidently say that it's not cyclopropane, because cyclopropane is saturated, and we can't add anything over a saturated molecule, which is why it has to be the other isomer, propene, because we can add over it because it's unsaturated, it contains a carbon to carbon double bond. Okay, now once we've done that, we put our 2 headings. So the reactants we are breaking, yeah, we always break reactants, and we are making products. Yeah, now we need page 10 of our data book. Okay, so make sure you do have that. But first, just write every bond that we see, okay? And I'm going to use a different pen for this. So, first bond that I see is, I see 1 carbon to carbon double bond. Yeah, score that off. Done. I also see 1 carbon to carbon single bond. Score that off. Yeah. I also see CHs. How many do I see? I see 1, 2, 3, 4, 5, 6. Yeah? And you may think you're done. However, what a lot of people do is they forget the one that we're adding. Okay, so try not to forget that. Okay, along here, what do we have? This time I see 2 carbon to carbon single bonds. Cross them off. 1, 2. I still see 6 carbon to hydrogens, count them, 1, 2, 3, 4, 5, 6, and I see 2 CI bonds, 1, 2, like that. Okay, now this is where the data book comes in. Okay, so carbon to carbon double bond is, so that's 1 times 6, 1, 2. The single bond is 3, 4, 8. So that's 1 times 3, 4, 8. The CH is 412, so that's 6 times 412, and the II is 151. Okay, we'll add that up in a second. We may as well just carry on. So we've now got 2 C single bond C's, so that is 2 times 3, 4, 8. We've got 6 CH's, which is the same, so that's 6 times 4, 1, 2. And we've got 2 CI's right here at the bottom, that is 238. So 2 times 238. Okay, now we can add it all up, so that's positive 617, positive 348, positive 151, and this is going to be positive, let's just do it on our calculator, so 6 times 412, positive 2472. Okay, this one, well, that one's going to be the same, that's going to be 2472. Whoops, sorry, be deliberate mistake there, make sure you're paying attention. Negative 2472. 348 times 2 is negative 696, and 2 times 238 is negative 476. Okay, now what we need to do is add both of them up. Okay, so let's do the breaking first. So 612 add 348, add 2472, add 151. What do we have? Positive 3583. And this one is going to be 696, add 2472, add 476, and that's going to be negative 3644. Okay, so just again, why not do this with a different pen? So delta H equals H of the breaking add H of the making. So the enthalpy change is the enthalpy of breaking plus the enthalpy of making, so that's going to be plus 3583. If you add a negative, it's just take away, so take away 3644, and what we're going to get, 3583 take away 3644, negative 61 kilojoules per mole. Yeah, just like that. Okay, so guys, well done if you got that. Again, quite a difficult question because we need to draw them out. Sometimes they are drawn out for you and it can make it a wee bit easier, but it is higher chemistry, so we push ourselves. Right, so this is going to be bond enthalpy, and this is going to be part 2 of bond enthalpy, because it does ever so slightly get a wee bit harder, but nothing that we can't handle. Okay, so what you need to know first is this definition here. Okay, it's called sublimation. Okay, and if I can just find my ruler, give it a wee subheading. Okay, so sublimation. So that is the process where a solid is converted directly into a gas. Okay, so usually what happens is you get a solid, you give it a wee bit of energy, it converts into a liquid, you give the liquid a wee bit of energy, it converts into a gas. However, with sublimation, you're going from a solid straight to a gas. Okay, there is no in between here. Okay, now that's what sublimation means. Now what we're interested in is the enthalpy of sublimation. Okay, and the nice thing about this is that the definition is at the bottom of page 10. Okay, so I'm just going to write that for you. So it is the energy required, sorry, I should have added that, the enthalpy of sublimation of carbon. Okay, that's what we're interested in. So it's the energy required to convert 1 mole of solid carbon into 1 mole of gaseous carbon atoms. Okay, and this has a very special value, and again, the good thing is you don't have to memorise this. Yeah, the delta H for carbon going from a solid into a gas is 716 kilojoules. Okay, you don't need to memorise that definition, you don't need to memorise that number, it's in the data booklet, it's found at the bottom. Okay, and you need to be able to use that information in questions. Okay, we are literally just going to go into a question. So again, question here, I want you to calculate the enthalpy change using bond enthalpy. I'm not going to write the, in fact, you know what, yeah, well, let's just not be lazy. So, calculate enthalpy change using bond enthalpies. Okay, and the reaction we're going to do, let me just think, so we're going to go for 2C solid plus 2H2 gas going to C2H4 gases. Okay, so that is what we're going to do. We're going to work out bond enthalpies. Remember, split your page. Just like that. Always do it beneath the arrow, remember, otherwise you'll end up forgetting this one or maybe even that one. Right, so let's draw them out. Now, we can't draw this out, okay? However, you'll notice, what do we notice? We notice it's a solid, yeah? So although we can't draw it out, we do have 2 times carbon solid going to carbon gases, okay? That's what you need to do. You need to, if you see a carbon in solid form, you need to convert it into a gaseous. Now, remember our definition, it's the energy required to convert 1 mole, okay? So if we've got 2 moles, we need to times that number by 2, okay? And then we've got 2 H, so we've got a HH there, and we've got another HH there. Remember, draw your molecules out. And then this one here, C2, H4, carbon to carbon, get your 4 hydrogens in, and what do we notice? We've only got 4 hydrogens. We've only got 3 bonds around the carbon. We need 4. What do? Double bond. Okay, don't forget that. Right, now once we've done that, we can do the fun stuff. Well, the funner stuff, if that's a word. Right, we are breaking the reactants and we are making the products. Yeah? So, we've already done the first one. We've got 2 times carbon solid going to carbon gaseous. Okay, just tick that off. 1, 2. We have 2 H H. Bonds. 1, 2. Done. Okay, let's move on to our making. What do we have? I see a carbon to carbon double bond. Yeah, tick that off. 1. And I see 4 carbon to hydrogens. Tick them off. 1, 2, 3, 4. Very important that we're crossing out our bonds. You don't want to forget. Okay, what people tend to do is they jump a step and they try and do it in their head. That's when you make mistakes. That's when you lose marks. So let's use our data book. Enthalpy of sublimation of carbon is 716 kilojoules, okay, per mole, but we've got 2 of them, so we need to do 2 times 716. That'll give us a positive, and HH is 436, so that's 2 times 436, and that will also give us a positive number. Carbon to carbon double bond is 612, and we're making it, so it's negative 612, and we've got 4 CHs, which is 412, so that is 4 times 412, and again that's going to give us a, oh, that's 1. Okay, that's going to give us negative 612, and if we just do all these in our calculator, so 2 times 7116, what we're getting, positive 1432, 436 times 2, positive 872, 612 we know, 4 times 412, that is negative 1648. Okay, let's add them up. So 1432, do the breaking side first, 872, that is positive 2304. Let's do the other one, so 612 add 1648, what we're getting negative 2260. Right, use a different pen, use our wee technique, so delta H equals enthalpy of the breaking add enthalpy of the making. So our change in enthalpy is positive 2304, sorry, take away 2260, and what we get in here, 2304 take away 2260, positive 44 kilojoules per mole. Okay, I think this is the very first positive one we've had. What does that tell us? It tells us that the overall reaction is endothermic. Yeah, beautiful, absolutely beautiful. Right, I say we go for a hard one now. Okay, so let's challenge ourselves. Right, so if that was, did I put question? Yep, I did put question 1. Question 2, I am going to be lazy this time. I'm not going to write the question out. It's the exact same question as before. I want you to calculate the enthalpy change using the bond enthalpies, and for this one I want you to, well, we'll do it as a class because you guys are going to have a bit of work to do after this. Half an oxygen. Okay, we've never seen that before. Gonna have a wee look, see what we need to do for that one. And then what does that give us? That gives us an alcohol in the gaseous state. Okay, what we're calculating, I'm just going to make a wee head, and what we calculated yesterday as well is the enthalpy of formation. So these 2 questions, okay, question 1 and question 2, we're calculating the enthalpy of formation. Now, what we mean by the enthalpy of formation is the energy change when we create a molecule made up of only the atoms. Okay, so it contains a carbon, hydrogen and oxygen atoms. So there, we've got carbon, plus hydrogen plus oxygen gives us that. So that's what we mean by enthalpy of formation. Okay? Right. First things first, let's draw them out. Okay, so we've got 3 carbon solids going to carbon gases. Yeah, so we can we can write that. Now we've got 4 H's, so draw them directly underneath each other like that. Okay, now we can't draw half an oxygen. Okay, so oxygen is that, O2 is O double bond O. We can't draw half of that, so what we do is we just draw half times that one. Okay, very important. And if we draw this out, what's this? This is going to be, well, I suppose it could be propan 1-ol or 2-ol. I'll just go for propan 1-ol, it's not going to affect it. Remember, OH, for bond enthalpies, draw. Don't just write OH, draw the bond in between, because a lot of people will forget that. Yeah, and it's a common mistake, happens to the best of us. So just be careful, make sure you are drawing that OH bond out fully. Right, again, get our wee headings. So we're breaking the reactants on the left and we are making the products on the right. Yeah? Right. Now, let's just count for every bond. Okay, so we've got 3 times carbon solid going to carbon gaseous, so that's that. Oh, I usually do this in a different pen, sorry. So that's that taken care of. We have 1, 2, 3, 4 HH bonds, okay, and we've got half of an O double bond O bond, okay, and we'll talk about what we do with that number. Very straightforward, you guys probably know. So just count it. We've got everything. Yep, we do. So let's go into this one. What do we see? I see 2 carbon to carbon single bonds. Tick them off. 1, 2. Yeah. I see 1 carbon to oxygen bond. 1. Tick it off. I see 1 oxygen to hydrogen bond. Don't forget that one. Yeah, a lot of people do. And I see 1, 2, 3, 4, 5, 6, 7 carbon to hydrogens. Tick them off. 1, 2, 3, 4, 5, 6, 7. Yeah. And I know every bond's been ticked off, so I've got it right. Yeah. No doubt in my mind, I've got that right. Right. Data booklet, enthalpy of sublimation of carbon, 716. So that's going to be 3 times 716. We've got 4 hydrogens, so 4 times 4, 3, 6. And we've got a double bond O, we've got half of a oxygen. Okay, so we just half the number. Okay, so it's just going to be half times 4, 9, 8. So we're just halving that number. Yeah, that's not tricky. That's easy. Yeah. 2 carbon to carbon single bonds, so that's 2 times 3, 4, 8. 2 times 3, 4, 8. A carbon to oxygen, there it is, 360. So that is 1 times 360. OH, remember in here it's HO, so just be careful, is 463. So 1 times 463, and we've got 7 CH bonds, so that's 7 times 412. 7 times 412. Okay, now we'll get a calculator. Okay, start with the breaking side. So 3 times 716, we've got positive 2148. 4 times 436 is positive 1744, and 498 divided by 2, so half it, that is positive 249. Yeah, easy. Right, 2 carbon to carbon single bonds, that's 348 times 2, that is 696 negative, remember. Okay, that's going to be negative 360, that's going to be negative 463, and 7 times 412 is going to be negative 2884. Okay, right, let's add all these up. Right, do the breaking first. So 2148, add 1744, add 249, what we're getting, positive 4141. Add up the making side, so 696, add 360, add 463, add 2884, what we're getting, we are getting negative 4403. Yeah, and collate it all together. Delta H equals H of breaking, add H of making, sub them in, so that's positive 4141, take away, yeah, 4403, and if we do that, we're back to exothermic. That is negative 262 kilojoules per mole. Yeah, and that's a high-end question. Yeah, a high-end question. Right, I'm going to make a wee note. It's a very important note. If carbon is already, okay, if it's already in the gaseous state, then we do not count it. So in other words, it has a value of 0. Okay, so if that was free carbons in the gaseous state, we've already converted it into the gaseous state, so it's 0. Yeah, it's only if it's a solid do we convert it into a gas, and sometimes the SQA put that in as a trick question. Horrible, I know, but that's what they do. Yeah, that's what they do to us. We've got to make sure we don't fall for it. Right, last one. Okay. Working out the bond enthalpy. Okay, I'm not gonna lie, this is hard. Okay, the good news, SQA doesn't really tend to ask it much, however they're well in their rights to. Okay, so it's up to me to show you how to do this. Now, I'm going to give you the question. There is only one question. After this question we're done. So one question, right, the enthalpy of formation of methane is negative 75 kilojoules per mole. Okay, so what we've been working out all these previous questions, we've been given the answer. Okay, now what the question would want us to do is work out the average enthalpy of CH. Okay, now I know some of you might be on the ball and be like, right, mean bond enthalpy, the average for CH is 412. SQA are never making it that easy. Okay, we don't even look at that value. So here's the equation. It is enthalpy of formation, so remember we're making a molecule of methane out of just the elements. So that is carbon and hydrogen to give us methane. Yeah? Right. Now, when I say this is hard, I don't mean it's impossible to get. What I mean by it is when a question like this comes up, it takes a wee bit of thinking to work out what to do. Okay, now we're having to calculate CH. Okay, so 4, in fact, let's not break the steps. Let's draw the molecules out. Like that. Okay, now what we're trying to work out, let's get our headings as well. So we've got breaking on the reactant side and making on the product side. Right, so we're trying to work out the average enthalpy of just a CH, okay? Now here we've got 4 CH bonds. We have no idea what that is because we're trying to work out what 1 is. Yeah, we don't know it. That's our question. We do know this though, okay? And we can use the data booklet. So, carbon solid, so it's just one of them. Carbon to solid going to carbon in the gaseous state, and that is 1 times 716. So that will just equal positive 716. We have 2 HH bonds, and again tick them off, 1, 2, yeah, so 2 times HH 436, so 2 times 436. We'll come back, in fact no, let's just do it now. So 2 times 436, and that is positive 872. Okay, now let's go into the last step. Delta H equals H of the breaking add H of the making. Okay, we don't have that. We don't. Okay, as far as we're concerned, that is this value here. Okay, so 4 times CH is H of the making. With me so far? I hope so. I've just very quickly forgot to add these two together, so sorry. 716 add 872, that is positive 1588. Yeah, now that there is our breaking, so we can add that in, positive 1588. Delta H, do we have delta H? Yes we do, it's up here. Yeah, it tells us the enthalpy of formation of methane is negative 75 kilojoules per mole, so we can add that in there, substitute that in. Okay, now we want to get this on its own. Okay, so again, this is where your maths comes into it. If you want to do the change side, change sign, whatever, so we want this on its own. Yeah, how do we get it on its own? We need rid of this number. We want to bring this over here. So what do? We take it away. Okay, so it's going to be negative 75 take away 1588, and if we do that in our calculators, we've got negative 1663, and that equals 4 times CH. Okay, now remember this is making, so this is going to be negative 4 times CH. Is that us done? No, it's not, because the question is not asked for 4 CHs, it's just asked for 1. Okay, so what we need to do is we need to get rid of this 4. So if we've got 4 H's there, take it over, change side, change sign, we need to divide by 4. So it's going to be negative 1663 divided by 4, and that would give us negative CH. Yeah, so let's do that in our calculators. So 1663 divided by 4, that is negative 415.75 equals negative CH. Cancel the negatives, so CH equals 415.75 kilojoules per mole. Whew, there it is. Yeah. Now, that is a difficult question, don't get me wrong, but see, when you break it down, we're not doing anything that much different. We're still following the same steps. All we're doing is rearranging this equation here. Yeah, and if you can do this bit, yeah, I mean everyone will be able to do this. Yeah, it's straightforward. If you can do this bit, you've cracked it. Okay, and that is bond enthalpy done. Boom, done. So what we're going to do, we're going to do some past paper questions now. You'll have today, and you'll have one more period to get them done, and that's us done bond enthalpy. Right, thank you.